Hello to anyone listening. This is my group's project on Olbers Paradox. The first question we ask is if the universe is infinite. The current working understanding of the universe is represented by models and theories like the Big Bang Theory, which is shown here, and general relativity. The Big Bang Theory shows us where time begins, a couple seconds into it, and at the present day. These concepts can seem mysterious or daunting to many people, but luckily there are simple concepts that will help grow our understanding of the universe. According to research and evidence gathered over the last several generations, astronomers have come to the consensus that the universe we live in is actually finite, meaning that it does not go on forever and that there is a limit to the number of stars and galaxies in our given universe. This means they had a beginning and that it could potentially have an end someday. How do we know this? For much of human history, people have asked questions like, are we alone? How many other planets are out there? And does the universe have a beginning and an end? Luckily, there's a simple way to answer one of these questions. Using logic, we can determine that the universe is not infinitely old, nor infinitely large, nor infinitely massive. One of the most commonly taught arguments for the universe being finite is called Olbers Paradox. The night sky is mostly dark. This is something that most people accept and take for granted, and rarely question. However, the darkness of the night sky actually provides some answers to one of the oldest and greatest questions in human history. How strange it is that the night sky is dark. First presented in 1823 by Heinrich Wilhelm Olbers, Thomas Digges, who proposed it in the 1500s or so, Olbers' paradox argues that if the universe were infinitely old, infinitely massive, and infinitely large, then the night sky would actually be fully illuminated rather than mostly dark with scattered bright points. So the night sky would be as bright as the sun. We will take a closer look into each of these 3 points of this argument to gain a better understanding of how they work together. We'll start with how we know that the universe is not infinitely large. If the universe were to extend to a maximum radius of less than 10 to the 18 megaparsecs, as we can see here, then only a fraction of the night sky will be covered with stars, leaving us with a universe that doesn't necessarily have stars in every direction. In the given universe that we live in, we see that this is true, and we can see it here. Next, how we know that the universe is not infinitely massive. There's only a limited number of stars and stuff out there, and not infinitely large, so infinite mass would mean infinite density. As we can see here, in this direction, there's 1 star, 1 star, 1 star, where over here there's an infinite amount of stars. Finally, we know the universe is not infinitely old. Light has a finite speed, which is around 2.99 times 10 to the 8 meters per second squared. Unlike everything else, distance is equal to rate times time. If the universe were infinitely old, then light would have had enough time to have been able to travel infinite distances. However, this is not the case. There is a horizon distance out there, the farthest away or back in time that we can see, otherwise classified as the most distant object that light has had enough time to travel from. Anything beyond this horizon is invisible to us. The portion of the universe lying within the horizon for a particular observer is termed the visible universe, as we can see here. The visible universe includes all of the points in space that have had time to send information to us in the form of light. We can use this information from distant objects which appear as they did long ago when the light was first emitted, to determine that the hot Big Bang occurred approximately 14 billion years ago. So the circle here represents the known visible universe. Light from the stars outside this circle have not had enough time to reach us at the center. We might not even see them due to the expansion of the universe. And here are references. Thank you for watching, and I hope you have a great rest of your day. Thank you. Bye-bye.